Hello everyone, myself I am Srivalya dear from Sri Venkateswara College of Engineering, Bengaluru, pursuing in first sem CSC, studying in shareholder section. Today's the major topic in physics is Heisenberg's uncertainty principle and the principle of complementarity. Introduction. Heisenberg's uncertainty principle and the principle of complementarity as a fundamental concept in quantum mechanics. Revolution our understanding of the physical world. Heisenberg uncertainty principle. There is a fundamental limitation to just how precisely we can know both the position and the momentum of a particle at a given time. That is delta x delta p greater than or equal to h by 2. H is equal to h by 2 pi. Then delta x delta p is greater than or equal to h by 4 pi. Negligible for microparticles like ball etc. but not for small particles. Heisenberg's uncertainty principle, proposed by Werner Heisenberg in 1927, it states that it is impossible to simultaneously know the exact position and momentum of a particle. The more precisely we know one of these properties, the less precisely we can know the other. Heisenberg's uncertainty principle, it mainly says that when the electrons are considered particles, we should be able to measure their positions and the momenta accurately. But Heisenberg shown that is not the case. The argument seems complex, but the result is simple. The uncertainty of position delta x and uncertainty in momentum delta p has this relationship. Delta x delta p is greater than or equal to h by 4 pi. These implications, the position is fuzzy if we know the energy accurately. We are concerned with the energy more than we are with the location probability of finding the electron correlates to orbital, not orbit. Mathematical formulation. Delta x represent the uncertainty in position. Delta p represent the uncertainty in momentum. Your third bullet. Example. Uncertainty principle. An electron is confined to a region with width of 5.00 in 10 power minus 11 meter, which is its uncertainty in its position delta x. Estimate the minimum uncertainty in its momentum. That is, delta x delta px is greater than or equal to h. So, delta px is greater than or equal to h by delta x. Then 6.62x into 10 power minus 34 of s by 5.00 into 10 power minus 11 meter. Then it answers 1.33 into 10 power minus 23 kilometers per second. Interpretation of uncertainty. The uncertainty principle is not due to experimental limitations, but a fundamental property of nature. It arises from the wave-particle duality of quantum objects. The more accurately we measure the position, the less precisely we can measure the momentum, and vice versa. Hence, the formula for the uncertainty principle is as follows. Delta x delta p is greater than or equal to h by 4 pi. The next topic is complementarity principle. It is introduced by Niels Bohr as an extension of the uncertainty principle. It mainly states that the certainty properties of the quantum particles are complementary and cannot be simultaneously measured with precision. Examples include the position and momentum, energy and time, or wave and particle nature. Complementarity, energy, velocity, time, position. Wave-particle duality. Complementarity arises from the wave-particle duality of the quantum objects. A particle can exhibit both wave-like and particle-like behavior depending on the experimental setup. This duality challenges our classical intuition about the nature of reality. Here we can observe in this diagram. Experimental verification. The uncertainty principle has been experimentally verified countless times. Examples include electron diffraction experiments and the double slit experiment. The results consistency confirm the fundamental limitation imposed by the uncertainty principle. Here we can observe the electrons the screen with the two slits, optical screen, the optical screen, the front view. Applications of uncertainty principle. The uncertainty principle has wide-ranging implications in various fields. It affects the design of electron microscopes and the particle accelerators. It also has implications for the stability of atomic structures and the behavior of subatomic particles. Philosophically implications. The uncertainty principle challenges our classical notions of determinism and causality. It introduces a fundamental indeterminacy at the microscopic level. It has sparked philosophical debates about the nature of the reality and the role of the observation. Quantum mechanics and the technology. Quantum mechanics, including the uncertainty principle, underpins many modern technologies. It includes mainly examples, includes transistors, lasers, and superconductors. Understanding and applying the quantum principle has led to the numerous technological advancements. Limitations and extensions. The uncertainty principle is not an absolute barrier to precise measurements. It sets off a fundamental limit but can be mitigated using advanced experimental techniques. Extensions of the quantum mechanics, such as quantum field theory, provide further insights into the nature of uncertainty principle. Conclusion. The Heisenberg's uncertainty principle and the principle of complementarity are the fundamental concepts in quantum mechanics. They describe the limitations and the complementarity of the measurement in the microscopic world. These principles have revolutionized our understanding of the physical world and have the practical application in various fields. Thank you.